On a clear night, far from city lights, you might glimpse a faint, milky band stretching across the sky. The Milky Way, our home galaxy. From Earth, we see only a thin slice of its true form, a flat, edge-on view of a vast spiral. But imagine soaring above the galactic plane, seeing the entire galaxy unfurl beneath you, a swirling masterpiece of stars, gas, and dust. Or picture plunging below the disk into the dark, mysterious regions few have studied. These forgotten dimensions, above and below, hold secrets about our galaxy's formation and fate. The Milky Way is not just a flat disk, it's a three-dimensional structure with vast, enigmatic regions. To truly understand our place in the universe, we must explore these uncharted territories. What lies beyond the familiar band of light in our night sky? The journey begins where the familiar ends. For centuries, we studied only what we could see: stars, planets, the galactic disk. But the real mysteries lie in the unseen spaces above and below, the immense voids and the invisible halo of hot gas and dark matter. This halo, though unseen, shapes our galaxy with its gravity, possibly outweighing all visible stars. Colossal bubbles of energy erupt from the galactic core, hinting at violent events and hidden structures. Are we sandwiched between unseen forces? Could these hidden regions reshape our understanding of galaxies and gravity? The familiar Milky Way is just the beginning. The true story lies just out of sight. The Milky Way is a barred spiral galaxy, a cosmic city of hundreds of billions of stars, including our Sun. From Earth, we see it as a glowing band, the combined light of countless distant stars. Its spiral arms, rich with gas and dust, are stellar nurseries where new stars are born. Our Sun is just one traveler among billions orbiting the galactic center. The galaxy's scale is staggering, 100,000 light-years across, yet only about 1,000 light-years thick. Trillions of worlds may orbit these stars, each with its own story. The Milky Way is a dynamic ecosystem, bound by gravity and filled with mysteries. We live in its thin disk, which is why the galaxy appears as a band of light, but most of the Milky Way's volume lies outside this disk, in the mysterious realms above and below. To understand our galaxy, we must look beyond the river of stars. Our solar system sits in a quiet suburb of the Milky Way, the Orion Arm, about halfway from the center to the edge. This location shields us from the chaos of the galactic core, allowing life to thrive. From here we have a clear view of the galaxy's structure, its arms, its band of light. The Sun orbits the galactic center at incredible speed, taking 230 million years to complete one circuit, a galactic year. Since its birth, the Sun has made this journey only about 20 times. Understanding our position is key to exploring the galaxy's hidden regions. The familiar disk is just the beginning. The real story extends above and below. To truly know our home, we must look into the great unknown. Our next leap is into the unseen. Let's rise above the Milky Way's disk, watching the familiar band shrink into a swirling pinwheel. We enter the Galactic Halo, a vast spherical region that dwarfs the visible galaxy. Here, stars are sparse and ancient, relics from the galaxy's earliest days. These stars follow eccentric orbits, remnants of galaxies long ago torn apart. The halo is mostly invisible, revealed only by its gravitational pull. The galaxy's rotation hints at a hidden mass, dark matter, providing the glue that holds everything together. The halo is the true boundary of our galaxy, extending far beyond the last visible star. It's a frontier of emptiness and ancient secrets, where the rules seem different. To understand the Milky Way's formation and fate, we must explore this ghostly realm. The answers lie in the darkness above. Floating like ethereal islands, globular clusters are some of the most spectacular objects in our galaxy. Imagine magnificent spherical cities of stars packed tightly together. Globular clusters are dense, perfectly spherical swarms of stars, bound together by intense gravity. About 150 known globular clusters orbit the Milky Way. Instead, they travel on highly inclined, elliptical orbits. These stellar relics are incredibly old, with ages estimated at 10 to 13 billion years. Studying them is like opening a time capsule, giving us a glimpse into the early Milky Way. This makes them perfect laboratories for testing our theories of stellar evolution. A self-contained galaxy in miniature, drifting silently through the great dark. Remnants of the building blocks from which the larger Milky Way was assembled. Beyond the ancient star clusters, the galactic halo holds a mysterious component. Imagine an immense invisible atmosphere, the circumgalactic medium, a vast reservoir of superheated gas. This hot halo contains a staggering amount of mass, visible only in high-energy X-rays. It is a dynamic and crucial part of the galactic ecosystem. This is the realm of dark matter. Our entire galaxy is embedded within a massive halo of this enigmatic substance. Its immense gravity prevents our fast-spinning galaxy from flying apart. A completely invisible sphere of dark matter. What is it made of? We simply do not know. Its presence is inferred only through its gravitational pull. A cosmic ghost whose presence defines the very structure and destiny of our home. As we journey to the outermost reaches of the galactic halo, our perspective shifts. The Milky Way, now a distant swirl of light, no longer appears isolated. Instead, we see the faint outlines of the cosmic web. This vast network of galaxies, gas, and dark matter spans the universe. It's composed of immense filaments connecting galaxy clusters. Galaxies are arranged along these cosmic threads. The Milky Way is tethered to this cosmic web. These filaments channel gas and dark matter into galaxies. This is how galaxies gather materials to grow and form stars. This connection means the Milky Way's evolution is linked to its cosmic environment. We are part of a dynamic, interconnected system. The space above our galaxy is a gateway to a larger structure. The journey reveals a universe of nested structures. We have now arrived at the doorstep of the cosmic web itself. Having explored the realms above the Milky Way, we now begin a journey in the opposite direction. We plunge downward, crossing through the bustling stellar disk and emerging into the space that lies beneath. This is a descent into shadow, a realm that mirrors the halo above yet holds its own unique secrets. As the brilliant galactic plane recedes, we find ourselves in a space that feels fundamentally different. The darkness is profound, deeper than the space above due to thick lanes of interstellar dust. This shadowy region is a place of hidden potential, a dark womb where the seeds of new creation lie dormant. The galactic wind carves out vast cavities, creating a turbulent landscape, a stark contrast to the halo above. The darkness below is not empty, it is alive with the echoes of cosmic violence. Venturing below the galactic plane, we discover the Fermi Bubbles. These colossal, hourglass-shaped lobes of plasma extend 25,000 light-years above and below the galactic center. Invisible to the naked eye, they glow in high-energy gamma rays and X-rays. Filled with cosmic rays and magnetic fields, these million-degree structures are remnants of a tremendous eruption. The prime suspect? Sagittarius A*, the supermassive black hole at our galaxy's center. The black hole likely feasted on a gas cloud millions of years ago, releasing energy and creating powerful jets. The Fermi Bubbles reveal our galaxy's cyclical nature, a reminder of the immense power nearby. Beyond the Fermi Bubbles, the region below the disk is a dynamic arena. Here, the galactic fountain circulates gas, superheated by supernova explosions. Gas expands outward, creating plumes that cool and condense, raining back onto the disk. This process redistributes heavy elements, vital for the galaxy's health. This space is also a graveyard, littered with debris from past collisions. The Milky Way has grown by consuming smaller galaxies, scattering their stars into streams. These stellar streams trace the paths of long-dead galaxies. High-velocity stars ejected from the galactic center roam free. Some are flung out at incredible speed, cosmic bullets escaping the galaxy's gravity. While the Fermi Bubbles showcase the explosive power of the galactic center, a more subtle but equally powerful force shapes the entire region below the disk, the immense gravity of the galaxy itself. The combined mass of billions of stars, vast clouds of gas, and the enigmatic dark matter halo creates a deep gravitational well. Everything in this space, from the smallest dust particle to the largest cloud of gas, is subject to this relentless pull. This gravitational field acts as an undercurrent, constantly tugging matter back toward the central plane, creating a cosmic sorting mechanism. This gravitational undercurrent plays a crucial role in shaping the structures we see. The densest materials, like the thick dust lanes, are pulled most strongly and tend to settle closer to the disk, forming the dark, obscuring layer we first encountered. Lighter, hotter gas from the galactic fountain can travel further out before it is eventually halted and pulled back by gravity. This creates a stratified atmosphere below the disk, a layered environment where density and temperature change with distance. It is an unseen architecture, a structure defined not by light, but by the invisible hand of gravity, organizing the chaos into a semblance of order. The influence of the supermassive black hole, Sagittarius A*, extends far beyond the Fermi Bubbles. Its gravity, while dominant only in the very center, contributes to the overall gravitational potential that governs the orbits of stars and gas clouds passing through this southern region. Stars that follow inclined, eccentric orbits are constantly pulled and torqued by this complex gravitational field. Their paths are not simple ellipses, but intricate, precessing rosettes that slowly shift over millions of years. The space below the disk is a dance floor where every object moves to the silent music of gravity, dictated by the combined mass of the disk, the halo, and the monster at the core. Ultimately, the journey below the galactic plane reveals a realm of profound duality. It is a place of darkness and debris, yet also a region of recycling and rebirth. It is scarred by the violence of the past, yet governed by the steady organizing force of gravity. The structures here, the bubbles, the fountains, the stellar streams, are not random occurrences. They are the logical consequences of living in a massive, active spiral galaxy. They tell a story of energy, matter, and gravity interacting on a colossal scale. The space below us is not a void. It is an integral, dynamic part of our galactic home, holding just as many secrets as the starry heavens above. We have journeyed high above the galactic disk and plunged deep into the shadows below, but now we must confront the greatest mystery of all, the mystery of dark matter. This invisible substance forms a massive, spherical halo around our galaxy. What if the dark matter isn't just a simple sphere? There may be a second, denser component of dark matter, a thin, concentrated disk. Our galaxy is a cosmic sandwich. We are living between two layers of matter, the visible stars and gas we know, and this hidden, ghostly disk of darkness. We are not just surrounded by dark matter. We may be living right in the middle of it. Our galaxy's disk is not the perfectly flat, pristine pinwheel it appears to be from a distance. When we map its structure with precision, a more complex and mysterious picture emerges. The outer edges of the Milky Way's disk are not level. They are warped, like the brim of a slightly bent hat. The northern edge of the disk appears to be bent upward, while the southern edge is bent downward. This colossal warp is a significant feature, a deviation of thousands of light-years from the central plane. For a long time its cause was a deep puzzle, a wrinkle in our understanding of our own galactic home. Furthermore, the disk itself is not uniformly thick. As we move away from the galactic center, the disk of stars begins to flare out, becoming progressively thicker. This flaring is more pronounced than we would expect from the gravitational influence of the visible stars and gas alone. Something else appears to be stirring the pot, puffing up the outer disk and creating this gradual, large-scale change in its structure. Both the warp and the flare are clues, giant signposts in the architecture of our galaxy, pointing toward unseen forces at play. They tell us that the Milky Way is not an isolated system in perfect equilibrium. It is being actively shaped by its environment. The gravitational influence of our nearest large neighbors, the Magellanic Clouds, is a likely culprit for some of this disturbance. These two dwarf galaxies are on a close pass with the Milky Way, and their gravitational tides are undoubtedly pulling and twisting our outer disk. But many scientists believe this is not the whole story. The warp and flare seem too significant to be explained by the Magellanic Clouds alone. This has led them to reconsider the shape of the dark matter halo itself. What if the halo is not a perfect sphere? What if it is tilted or twisted relative to the galactic disk? This unseen gravitational architecture could be the key. If the massive dark matter halo is tilted, its gravitational pull on the disk would be uneven, creating exactly the kind of large-scale warp we observe. It would be like trying to spin a platter on a tilted surface. It would naturally wobble and warp. This invisible, misaligned scaffold would be the hidden architect of our galaxy's large-scale shape. The beautiful, serene spiral we see is merely the visible response to a hidden gravitational conflict, a misalignment between the world of light and the world of darkness that defines our cosmic home. When we combine these clues, the potential dark disk, the warped and flaring structure, and the energetic bubbles below, a profound new image of our galaxy comes into focus. The Milky Way is not a static object but a dynamic arena where unseen forces are constantly at work. We are being shaped, influenced, and perhaps even sandwiched by energies and substances that lie beyond our direct perception. The familiar galaxy of stars is just the visible froth on a much deeper, more mysterious ocean of cosmic forces. These forces are the true, hidden architects of our galaxy. Consider the possibility that we are caught between two powerful phenomena. Below the disk, the explosive energy from the supermassive black hole pushes outward, creating the colossal Fermi Bubbles and driving a galactic wind. This creates a pressure from beneath. From above, and all around, the immense gravity of the dark matter halo pulls inward, holding the galaxy together and shaping its rotation. Could these opposing forces, the outward push from the core and the inward pull of the halo, be creating a kind of cosmic pressure cooker, a dynamic equilibrium that dictates the very environment we live in? This leads to one of the most intriguing questions in modern astronomy. Are these hidden forces connected? Is the flow of gas into the galactic center, which fuels the black hole's outbursts, regulated by the structure of the dark matter halo? And do the outbursts from the black hole in turn affect the distribution of gas and even dark matter in the halo? We are beginning to see the galaxy not as a collection of separate parts but as a single, interconnected ecosystem. The black hole at the core, the stars in the disk, and the dark matter in the halo are all part of a grand feedback loop that has been unfolding for billions of years. Ultimately, the mysteries hidden between the stars force us to confront the limits of our own perception. Most of our galaxy's mass is invisible. Its most powerful energetic events are seen only in high-energy radiation. Its true shape is sculpted by gravitational forces we are only just beginning to map. To understand our home, we must learn to see the unseen. We must piece together the clues left behind in the motions of stars and the faint glow of distant gas. The true nature of the Milky Way is a secret whispered in the language of gravity and darkness, and we are only now learning how to listen. Could the vast, lonely regions of the galaxy be home to something unexpected like intelligent life? The galactic disk might be too dangerous for a civilization to survive for billions of years. The galactic halo offers a safer cosmic neighborhood. Imagine a spacefaring species drifting silently through the halo, masters of their environment, hidden from younger civilizations. Perhaps they hide for protection, understanding cosmic dangers and the rise and fall of countless species. By residing in the halo, they would be almost impossible to detect, using technologies invisible to our instruments. What if the oldest, wisest residents moved out to the quiet countryside of the halo long ago? They might be watching us, waiting for us to reach a certain level of maturity. Imagine a personal journey traveling straight up or down, away from the galactic disk. Picture yourself in a vessel starting from our solar system. The familiar constellations would distort and disappear, replaced by a new, three-dimensional perspective. The band of the Milky Way would broaden until you breach the main plane. As you ascend into the halo, the stars would become incredibly sparse. Looking out into intergalactic space, you would see the faint smudges of other galaxies. Now, imagine the journey downward. After passing through the disk, you would enter the realm of shadow and dust. Ultimately, both journeys would teach you the same humbling lesson. The universe is not just what we see. Our journey is now complete. We have soared into the ancient and ethereal halo, witnessed the ghostly cities of globular clusters, and felt the invisible presence of dark matter. We have plunged deep below the disk, where the violent echoes of our galactic heart still reverberate. We have peeled back the layers of our cosmic home, looking beyond the river of light. What we have found is a universe far more complex and mysterious than we ever imagined. The Milky Way is a living, breathing, multidimensional structure, a place of profound dualities. The space above and below us is an integral part of our galactic ecosystem, where the past is preserved, the future is forged. We are only at the beginning of this new chapter of exploration. The next time you look up at that faint milky band stretching across the sky, remember the immense spherical halo that surrounds you. Our galaxy is more than just our home. It is a grand and ongoing mystery. The journey to understand it is the greatest adventure of all.